Hey guys, Marini here with another stats video. This is for Friday. We're going to do something called a paired t-test. You could pause the video and read this question. No do now today. We'll just get right down to business. All right, now that you've read this, we have a chart here. We're looking for, is there evidence at the alpha equals 0.05 level that caffeine withdrawal increases depression score? So one of the things I want to point out is that this isn't two different groups of people like we've been doing. Chapter 10's been all about inference for two samples, but this example is actually, there's 11 people. They took a depression test, whatever the hell that is, and they got a test score. And then they took another depression test, taking a pill that mimicked caffeine. So they took a depression test on regular caffeine and got these scores across the top here. And those numbers are pretty low. And then they took a placebo, we'll talk about that in a second, and took the depression test and got these depression scores, which are higher, which might make sense because their depression will be higher because they're not taking their regular caffeine. So in this experiment, this is something that we talked about back in chapter 4, matched pairs, where it's not two different groups of people, it's one group of people receiving two different treatments. So each person, each of these 11 individuals randomly took a pill. It was either caffeine or a placebo. They took both, but they don't know which one was which. And they took a depression test after each of those pills and got these scores. And we're looking to see, is there evidence that caffeine withdrawal is increasing their depression score? And it does look like the placebo depression test has obviously higher numbers, but is that actually enough evidence to prove this or to say that caffeine withdrawal increases depression score? So the first step of this is step 1. We want to test the claim about the true mean difference and I'm going to write down how I'm going to be doing this difference. We're going to be subtracting these test scores. So I'm going to do placebo minus caffeine. For the reason being that depression test score, when you do placebo minus caffeine, it's going to probably be a positive number. And that's what I feel like doing. So true mean difference, placebo minus caffeine in depression test score for subjects like these. We also need a null hypothesis and an alternate hypothesis. This is going to be a little bit different. It wouldn't be appropriate to say mu1 equals mu2 here because that's implying that you have two different samples. We have one sample of people here. So what we say here is that there's going to be something called mu d. Mu d is the mean difference. The mean difference in their depression test score. And we're going to assume in the null hypothesis that that's 0, meaning that there is no difference in their depression test score when they took the caffeine and when they took the placebo. It's the same, no difference at all. And in your you're going to say mu d, either it's going to be not equal 0 or greater than or less than, kind of depends on what we're looking for. We're looking to see if there's evidence that caffeine withdrawal increases depression score. And I set it up in a way where I'm doing placebo minus caffeine. So if you think about it, placebo minus caffeine, if we're looking to see if there's evidence that caffeine withdrawal increases depression test score, that means the people with the placebo would have a higher depression score than the caffeine. And when you did that subtraction, you'd be getting positive numbers. So mu D is greater than 0. If you want to do caffeine minus placebo, that's fine too. You would have to switch your symbol to a less than. And then again, I'm just going to write down over here what mu D is. Okay, step 2. Can't say 2 sample t-test. Can't say 2 sample anything. There's only 1 sample. This is called a paired t-test. And that's not in the calculator. So in terms of calculator, you're just going to go to t-test, which we did back in chapter 9. And that is t-test. That's number 2. But we're not going to go there yet because I have a couple things to show you. So for paired t-test, you're going to check some conditions. The first condition being random. And I want to explain something that I started to explain in the Google Meet today, but not everybody was there. This is from an experiment with volunteers. They didn't just randomly assign people on the street, here, you take this caffeine pill, you take this placebo pill, here's a depression test, Mr. Smith, and, let's see how you do. That's weird. It's also illegal. These people volunteered, and they were randomly picked to get either the caffeine pill or, well, actually, they weren't randomly picked to get the caffeine pill or the placebo pill. The order of the treatment, the order in which they took the pills was randomly decided. So I'm just going to say this was random assignment of treatment. And something else that I explained in the video is that when you're doing stuff from experiments, since they're volunteers, it's just kind of assumed that they're all, independent of one another. You're not taking a sample and then taking another sample of people. So you don't have to really check the 10% condition, but you do have to check normal. And since the sample size is only 11 subjects, we can't use the central limit theorem. So we're going to have to draw a box plot. Now, we're not going to draw a box plot for caffeine, and then we're not going to draw a separate box plot for placebo like we were doing yesterday. We're going to draw a box plot for the difference of placebo minus caffeine. And the way that you're going to get that box plot is you're first going to type in data into L1 and L2. So you can make depression L1, caffeine L1, and you can make the placebo L2. And I'll show you my calculator in a second. Okay, so you can see there I have L1, L2 already set up. What I want to do is I want to make a third column, L3. And I want this third column to be the difference. So first of all, we got to decide, are we going to do L1 minus L2 or L2 minus L1? Well, I set it up to be placebo minus caffeine. So that would be L2 minus L1. So what I'm going to do is I'm going to go up to L3. I'm going to switch that to be L2 minus L1. The way you do that is you push second, L2, minus second, L1. And if I just go down here, it subtracts all of those numbers. You could see L3, the first number there is 11. That's the 16 minus 5. That's a difference of 11. So now we're ready. Well, actually, no, we have to make the box plot. So we'll do second y equals, plot 1 on, and make sure your X list says L3, and then go to graph. You could do zoom stat, and there's the box plot. And in terms of, that doesn't show any strong skewness, doesn't show any outliers, so I'll write that down. And then when we go to step 3 and do our formula and we get our numbers to put in the formula, you're gonna go to stat, tests, and you're just gonna go to regular t-test. There's no paired t-test option. So you're gonna hit enter on that, and you're gonna make sure that you're on data, not stats. You'll leave mu0 as 0, that was from the HO. The list is from L3. Frequency, leave that alone. I gotta change this to be greater than symbol because that was what we had in our HA. So push enter on that, go down to calculate, enter, and you'll see that your T is 3.53. The p-value is 0.0027 or 0.003, however you want to round. That X bar and that standard deviation, we need that also because that's what's going to go in the formula. So let me go back to OneNote, finish up the problem, and then I'll talk to you guys in the morning. All right. So, as we said earlier, we got to draw the box plot. Doesn't have to be perfect. All right, now we go to step 3, formula. Formula for a paired t-test is T equals X bar D minus 0. It's just one sample, so it's back to the way we did it in chapter 9. We don't need the big radical or anything like that because it's not two different groups. And from the calculator, X bar D was 7.36. And the standard deviation from the calculator was 6.91. Sample size is 11. The T that I showed you was 3.53. The p-value that I showed you was 0.0027, which is really low, so it's significant. We're going to reject the HO. We have evidence that caffeine withdrawal increases depression score. So let me just write that down. All right, that is how you do a paired t-test. And this is the last test I think that we're going to do, depending on what AP people say. All right, yeah, I will send this out to you guys, and we'll talk